On today's notes about decimals, if you printed out the sheet, then you can either cut it in half, going right down the middle, and put the place value chart on the left side of your journal and the other side on the right page. Or you're welcome to just fold it in half and glue it into the right-hand side of your journal. If you are just taking the notes by hand, I recommend putting the place value chart on the left side page of your journal and this right side onto the right side of your journal. The reason I've given you this place value chart is because the biggest mistake I'm seeing students make is not understanding or forgetting about the concept of lining up your decimals before you compare them. So use this place value chart. I've given you a lot of different lines so that you can use it to compare to see which number is bigger, or use it to add or subtract decimals until you get back in the habit of lining up your decimal every time before you do anything else. So the big spot that we're going to fill out is comparing decimals, figuring out which one is bigger. So on this, the first thing you do is you have to line up your decimals. And then we're just going to compare, starting at the left, each digit until we find something that's not the same. So we're going to compare 0.1297 and 0.15. So the first thing I'm going to do is I'm going to go ahead and just put them both in here. So 0.1297, and then my other one is going to be 0.15. And then what I'm going to do is I'm going to just compare, starting at the left, each one of my digits. So if I'm looking right here, the very left in the 1 spot, my zeros are the same. So there's nothing to do there. And my 1s in the 10th spot, they're the same. So the first time I have a difference is right here. So this is going to decide. This is the place value that's going to decide which number is bigger. So I've got 2 and I've got 5. Well, 5 is the bigger number, so 5 is bigger. So that means that the bottom number, 0.015, is bigger than 0.1297. And it all had to do with the first place value that was different. A couple of other things I want you to notice on these notes is down here with the equivalent decimals. Following kind of the same concept. If I look at this model as a decimal, I have one whole, that's going to be the number in the 1s. I have my decimal place, and then I've got a box partitioned into 10 parts. 5 of the 10 are shaded, so 1.5. Or if I wrote it as a fraction, I've got 10 plus 5 more is 15 over my partition of 10. But another way we could look at it is one whole and then dividing the whole into 100 boxes. So that's one whole, my decimal place, and then I've shaded in 50 of my 100 boxes. But if you look at the model, 1.5 is the exact same size as 1.50. And if you can just keep that straight in your mind, you'll never mess up decimals again.